A 115-year-old company lost $31 billion in market value in a single day. The trigger was a blog post demonstrating how an AI tool called Claude Code could map and modernize legacy financial software in quarters instead of years. For decades, global financial systems have relied on the massive physical hardware and legacy code frameworks shown here. When the market realized AI could untangle that architecture, the valuation of the companies maintaining it collapsed. That same cycle of sudden technological obsolescence is hitting the traditional third-party software stack that Amazon sellers rely on today. Yet, despite the urgency, data from MIT research shows that 95% of AI initiatives fail to meet their basic operational objectives. Sellers are caught in pilot purgatory. They test a disconnected optimization tool here and an automated repricer there, but these isolated experiments never scale into actual infrastructure. The root cause of this failure rate is an operational error. Sellers are treating LLMs like search engines. LLMs, or large language models, are AI systems trained to process and generate human text based on the inputs they receive. Because operators use these tools like chatbots, they are trapped in a cycle of manual friction. Every morning requires downloading a CSV, pasting it into a chat window, and writing a conversational prompt. A CSV, or comma-separated values file, is a simple text format used to store tabular data like spreadsheets. Meanwhile, elite operators are discarding their $500 a month software subscriptions entirely. They are replacing off-the-shelf dashboards with custom, autonomous AI agents that run specific workflows without human prompting. The operational focus is shifting away from writing individual prompts toward building persistent agentic architectures. Surviving this shift requires abandoning the chat window. Operators must build a three-layer agentic architecture consisting of logic, data, and guardrailed execution. The baseline flaw of conversational AI is its total lack of permanent memory. The moment you close a browser tab, the AI forgets everything. It loses your specific ASIN margins, your custom fulfillment fees, and your brand voice. An ASIN is a 10-character unique alphanumeric identifier assigned by Amazon for product identification. This memory loss directly causes AI hallucinations. Without persistent rules, the system is forced to guess, fabricating data and degrading the reliability of the entire workflow. The operational replacement for prompting is context engineering. Meta recently paid $2 billion to acquire Manus AI specifically to own this capability at scale. The core mechanism of context engineering is the skill file. This is a modular, plain-text markdown document that stores your exact business rules permanently. A typed prompt dissolves into smoke the moment the session ends. A skill file, however, locks into your database as a structural anchor for every future decision the AI makes. An operator can hard-code specific FBA reimbursement parameters directly into the file. The rule dictates an item must be marked damaged and time elapsed greater than 60 days. The AI references these exact parameters every time it evaluates an inventory ledger, ensuring total consistency. By structuring logic this way, you turn an error-prone chat session into a permanent, executable business asset that compounds in accuracy over time. But logic requires material to process. The best skill file holds no value if it is evaluating stale, manually exported data. Traditional software companies fail to solve this because they rely on fragile, single-use API connections for every individual tool. An API is a software intermediary that allows two separate applications to talk to each other. The architectural solution to this bottleneck is the Model Context Protocol, or MCP. MCP acts as a universal bridge, bypassing isolated data silos to establish a direct, standardized connection between the AI and your live databases. It provides synchronous, continuous access to your proprietary information without custom coding. Operationally, the AI no longer guesses your performance metrics. It executes a live SQL query directly against your ad account. SQL is a standard programming language used to manage and extract data from relational databases. The AI absorbs real-time numbers, instantly factoring in your exact ASN margins and evaluating an ACost of 29. Historically, automation scripts break the moment they encounter complex logins, dynamic drop-down menus, or a sudden update to the Amazon user interface. The technology that bridges this final execution gap is Playwright MCP. Playwright abandons fragile coordinate-based clicking. Instead, it reads the underlying DOM structure of a website. The DOM, or Document Object Model, is the programming interface that represents a web page as a structured tree of elements. By reading the site's architecture, the AI identifies the precise target, navigating dynamic interfaces exactly the way a human operator would. The agent can now log into Seller Central, adjust individual campaign bids, and flag low inventory levels entirely on its own. Playwright removes the friction of human interface navigation, closing the final loop between data analysis and real-world execution. Autonomous execution introduces a massive operational risk. When machines act independently, errors compound at machine speed. Engineers define this risk as the blast radius. It measures the scale of damage caused by a single, confidently wrong decision made by an AI. An unconstrained AI agent designed to negotiate a car discount recently glitched and carpet-bombed a user's contact list with 500 outbound emails in seconds. Even Amazon's own internal AI coding tool, Kira, deleted an entire AWS environment from scratch because it was deployed without proper oversight. In an ad account, an autonomous error cascades through hundreds of campaigns before you even open your laptop. The mandatory architectural solution to this threat is the 70-30 rule. You retain 70% human control and delegate 30% execution to the machine. Under this model, the execution halts at a structural checkpoint. The blast radius is contained entirely. You implement this by hard-coding constraint rules directly into your skill files. You write explicit commands like, never execute bulk changes. Always send a Slack notification for approval. True, scalable autonomy elevates the human to an approval checkpoint, while the AI handles the hazardous preparation. The fully assembled agentic stack relies on live data via MCP, specific business logic via skill files, and autonomous action via Playwright. That entire workflow is then wrapped in a human-in-the-loop guardrail to ensure operational safety. The traditional e-commerce moat is gone. Competitive advantage no longer goes to the seller who pays for the most off-the-shelf software dashboards. The new moat belongs to operators who build proprietary agentic systems, perfectly tailored to their own unique business logic. The losing seller remains stuck in spreadsheets, discovering margin decay and fee changes days after the capital is already lost. The winning seller wakes up to a Slack notification, detailing perfectly optimized bids and flagged inventory anomalies, ready for a single-tap approval before their first cup of coffee. To achieve this, you have to stop interacting with software and start managing an autonomous workflow. Build your logic files, connect your live data, and establish your safety guardrails before your competitors scale their own AI operations.